In this video, we are going to try to learn how we can use neural network from TensorFlow. Given a certain dataset, we will identify if a given input belongs to a particular class. The dataset that we will be using is a dataset from Kaggle. This contains the measurement of the penguins, which usually are the bill length, bill depth, flipper length, and body mass. These are the numerical data that we will be using for us to classify if a certain penguin belongs to the group of Adelie, Gen 2, and the last one is the chin strap. We will be using Python in Jupyter Notebook to implement the neural network in TensorFlow. Okay, so let's get started. Before going further, watching this video, making sure that you have already installed the Anaconda package management deployment software. If not, then you can go to the Google and start downloading the Anaconda software. So from this result, you can check out one of the page here and download a copy of the Anaconda Navigator. So in my case, I have already installed one. So what we will do now is to prepare the environment that we will be using for creating our simple project. So the environment will help us to centralize the needed packages for our simple project. So to start creating our environment, at the bottom you have here the create one. Click the button create and then type the name of your environment. I will name it test. And then select the version of your Python. So I will be choosing 3.10.8 and then click create. So the test environment has already been created for us by the Anaconda Navigator. The next step that we will do is to select this one. And since it has already this green circle, it indicates that this environment is already selected. So next, what we will do is to install the needed package for our environment. So for our simple project, we will be needing the TensorFlow and the TensorFlow dataset. So let's look for these packages by going to the search bar and type here TensorFlow. And we check the TensorFlow for machine learning library and the TensorFlow dataset. After placing the check marks, click the apply button and wait for it to finish. As of this moment, it will try to list down all the dependencies of the TensorFlow and the TensorFlow datasets. So these are all the dependencies of the TensorFlow machine learning library and the TensorFlow dataset. So let's click apply button. So let's just wait while the Anaconda Navigator is preparing everything for us. Okay, so the Anaconda has already finished deploying all the packages that we need for our environment. Now let's move to our home and install the Jupyter Notebook by selecting the Jupyter Notebook and click the install button. The Jupyter Notebook is an editor for Python. We will be using this one to write our scripts, and using Jupyter Notebook, it will be easier for us to immediately see the results as we type our scripts. So we have already installed the Jupyter Notebook, so we are now ready to start writing our script for our simple project. Let's open our Jupyter Notebook by clicking the Launch button. And then from here, let's select the New button and select Python 3. So this will open up a new page for our Jupyter Notebook. In this first cell, we will write the import statement for our TensorFlow. And press Ctrl Enter to verify if we have written everything correctly. Okay, so there were no errors, so let's proceed to the next cell by clicking the plus sign. Next, let's load our penguins dataset. So let's load this to a variable ds_split. So this dataset has been already pre-processed for us. So the file name is processed, and we are going to split this, and then let's try to see what's inside of this data set by creating a data frame from tensor dataset. And then let's print the result of this. Okay, so there you go. So these are the features including the species. So basically under the features, these are the measurement of the penguins, which includes the bill length, bill depth, body mass, and flipper length. So for the species, it is in the form of numeric. So 2 here refers to the Gentoo species, and 1 refers to chinstrap, and 0 refers to Adelaide species. Okay, so let's continue working, and let's create another new cell. And this time we are going to split our data set, 20% for the test data set and 80% for train data set. Now let's load our pre-processed penguins using 20% for our test data and 80% for our training data. So what we will do is to copy and paste this line here, and we will indicate that we need to split this 20% for the test set and 80% for the training set. We're going also to set this as supervised, and we have to include the info of this dataset. And we will store that info from this variable info. After that, we have to get the first split using the ds variable, ds test, and specify here the ds split using the first split, and the second split is the 80%, and we will call this train. Okay, now let's convert this dictionary into data frames using the TensorFlow. Okay, so let's write here df for data frame is equals to dft that as data frame, and we will feed here our test together with the info, and let's just copy and paste this and use the des train for df train. Then let's try to see what's inside of the df test and df train variables by printing each of them. So let's print the df test and print as well the df train. Then let's run these lines, and for the df test we have 67 rows, and for the df train we have 267 rows. So the columns here refers to the feature and species. So both of the frames or data frames contains the same number of columns. Okay, so let's create a new cell and let's start designing our model. So let's write our model by typing here the model variable followed by the TensorFlow, the alias is tf, and we will use the keras, that's sequential, so what we did here is we used the tf keras API because this is a preferred way to create models and layers. This makes it easy to build models and experiment while keras handles the complexity of connecting everything together. The sequential model is a linear stack of layers. This is the sequential. Each constructor takes a list of layer instances. In this case, we have the layer dense with 10 nodes of each and an output layer with 3 nodes, representing our label prediction. So this is the 3 nodes representing our Adelie, Chintrap, and Gentoo species. The first layer input shape, this one, is a parameter that corresponds to the number of features from the dataset. So basically we have 4 columns, and these are the measurement of the penguins, starting from the flipper length, bill depth, and body mass. And for the activation function, it determines the output shape of each node in the layer. Without them, the model would be equivalent to a single layer. So actually there are many activation values, but ReLU is the common type for hidden layers. Okay, so what we will do next is to extract the features and labels from our training set. So this will help us to optimize our model. So let's write here ds train. So the number of rows we have is 267. And then to extract the features and the labels, we have to write here features, labels. Then let's write here next. And then the iteration. And then we have to supply here the ds train batch. Okay, so let's run this. And let's try to see what's inside of the features. Okay, so there you go. And for the labels, okay, so everything is fine. So let's move to another cell and let's compute and measure the performance of our model by computing the loss as we train our model. So this measures how off our model's prediction from the desired label. In other words, it helps us to determine how bad the model is performing. So we can compute for the loss by creating a loss object. Then let's write here that tf.keras. The parameter logits here will return us the estimated predictions that the classification module generates. Now let's press Ctrl Enter, and we will create a helper function that will help us in computing the loss of our model during training. So let's define a function here. Let's name this loss with 3 arguments or 3 parameter variables: the model, x and y, and the training. We will say here that y will contain the value of our model containing the x and having a training value equals to training. And then after that, we will return the loss object with the y true is equals to y followed by y predicted or y pred is equals to y underscore. Then let's try using this function if you can actually produce a result from this. Okay, so let's press Ctrl Enter. So we have a problem. Okay, so we're missing some S here. Let's run this again. Okay, so it should be in capital letter F. Ctrl Enter again. There you go. So we have a loss that is almost 1%. So let's add a new cell. So this time we will calculate the gradient that will help us to optimize our model. So we'll be creating a function, a gradient function, wherein the inputs for this gradient function are the features and labels, and the result of this will be used for optimizing our model. Okay, so let's start. Let's define the function. Let's write here def. We will name this function grad. Supply the model parameter here together with the inputs and the target. The result from this function will be used in an optimizer. We will be creating an object, optimizer object. So we will use that to optimize the result from the gradient function or the grad function. So let's try running these lines. So everything went well. So now let's create the optimizer. For the optimizer, we will apply the gradient that we have created so that it will minimize the loss. So let's create now the optimizer. So let's write here optimizers or just optimizer. So we have several types of optimizers and keras, and what we will be using is the SGD. And we will supply this with a learning rate of 0.01. Okay, so let's run this line. Okay, then let's add another cell. Then this time, let's try to calculate and optimize a single step. So using the grad function. So let's write here the loss. So this is just a variable to see that we have gained a value from the grad function, the gradient value. Then we call the grad function supplying the features. We start with the model followed with the feature, and the last one is the label. Okay, so we forgot letter S here. Okay, so there you go. So now let's try printing these values. So let's write here print. Okay, so there you go. So we have the initial step. Then let's try to optimize this so we can see if it was able to reduce the error. Then on this side, we will call the loss function that we have created just a moment ago. And we will supply here the model. Okay, so let's try running this again. And we have an error. Okay, so it should be underscore. And there you go. So we were able to reduce the loss value. From the initial loss, we have 0.98. So after one step, it became 0.97. Now let's create another new cell. And this time we are going to train our model. So the first thing that we need to do is to keep track of the training loss and the training accuracy of our model. So let's write here train loss results is equals to empty and then train. Let's define the number of epochs, meaning the number of times that will uh, our model will pass through the training. So let's write here num epoch. Let's define this around 200, and then let's iterate through each epoch, and then let's get the mean of the keras as we iterate through the epochs. And we will be using the sparse categorical accuracy. We are now going to start iterating to our dataset to start the training of our model. So for x, y, in our DS train batch, we are going to compute or get the loss as well as the gradient or the grads from the grad function supplying our model, the x and y. And then we will optimize this value using our optimizer. Then we will keep track the progress of the loss as we train our model as well as the accuracy. And then we will append all the results to our training loss results. And for the last pass-through of our epoch, we will determine if it contains a remainder of 0, and if it has, we'll print the results. So let's apply here the format specifier. So let's print the average loss and then the accuracy result. Let's put this around here and here. Okay, so let's try running this. Control Enter. So we have an error. It should be misspelled. We should add L here. And then let's try this again. There is no S around here. Same with here. And let's try running this again. On the first pass through, so we got 6% loss until at the last pass through we got 61% loss. So as we move downward, the loss becomes lesser and lesser. So we can actually fix this one if we are going to decrease the number of batch of training. We can go back to the first segment of our code wherein we set here the batch equal to the number of rows that we have. So here we can set this to, let's say 32, and then run this, and then run the remaining segment of scripts. And then on this part, okay, so let's try turning this F into percent so that when we run this, it will give us a percent representation. The observation that we got from here is that the smaller the batch size we feed, the slower the training becomes. So let's put the batch size around 60. Then let's try running this again by running each cell. So we can actually specify any value for our batch size. So we set this to 60 to 32, and the results show differently. But in our case, we can just stick with, let's say, 32. Then let's run all of this script. Okay, so let's summarize the things that we wrote here. So the first thing is that we iterate in each epoch, and one epoch is a one pass through to the dataset. Then second, within an epoch, we iterate over each example in the training dataset, grabbing its feature X and label Y. And the third one, using the example features, we make predictions and compare it with the label. We measure the inaccuracy of the prediction and use that to calculate the model's loss and gradient. Then we use the optimizer to update the model's parameter. This actually improves the training of our model. Then we keep track of the visualization of our status, and then we repeat the same for each epoch. Okay, so this time let's test the accuracy of our model. So let's create some dummy variables. So let's write here test accuracy, and let's create a batch dataset. So we'll only be using 10. This ds underscore test was the variable that we used in separating or splitting our dataset just a moment ago. So if you can still remember, on this part, we split the 20% and use that for our testing. So this is not the portion that we will use, that 20%, but only 10 from its content. So let's write a loop here. Then let's try to get the logits of our model. So this is a raw prediction from the model. And then after that, we are going to create a prediction variable wherein it will contain the highest rank from the logits using the argmax of the TensorFlow. So let's write here tf.math. We feed here the logits, and the output will be an integer. Then we test the accuracy by using the prediction as the argument together with the y label or y values. Then let's print the result. Misspelled, it should be u. Misspelled again, it should be u. Okay, so there you go. So the accuracy is about 97%. So now let's try testing our model. by giving it a query data. So on this line, let's create a query data, and then let's name this predict dataset. And let's convert this dataset into a TensorFlow dataset. And then let's try using random numbers for generating these datasets. So let's try 0.3. Then let's write here the variable that will hold the result of the prediction. So let's call our model, and then let's feed here our query data, the predict dataset, and we will set the training to false. And then we will iterate to each result that we get from the prediction. So for I, we will check the logits of the prediction. Then we will get the index of this logits. We will name this IDX. So take note that we are only interested to the highest value of logits. So that is why we are using the argmax. Then we feed the logits to the softmax so that it will give us the true probability of the predicted value. So let's write here tf.nn.softmax. Take note that the value of the logits are just a raw prediction. So in order for it to turn it into a real predicted data, we have to supply to the softmax. And then supply here the class IDX. And then we have to get the classification label. And for now, we haven't created yet. So let's create our classification label at the top. So let's name this class names and supply this with, let's say the first one is Adeli, followed by Chinstrap, and the last one is the Gen2. So let's write here class names, and then we will feed here the class IDX. And then let's print the results. Okay, so let's try running these lines. So we have an error, so it should be underscore. So let's run this again. Forgot a comma here. Let's run this again. So let's run this again. Okay, so there you go. And we have now this result. Okay, so let's put some additional formatting here. Let's try adding a period here. And there you go. Let's write this again. Okay, so there you go. For the item 0, it was predicted as Adeli. So this is the Adeli. The second one is this as well, Adeli. And the last one is Chinstrap. So we can make some changes here. So let's try. Okay, so there you go. It changes to Chinstrap. And let's change this to 1 and 2. Changes to Gento. Okay, so that's all for this video. Thank you for spending your time watching this lecture. And I hope that you learned something from this video. So thank you for watching, and bye-bye.